Good morning. Please go back and watch all the videos from the beginning of continuity till now. Now, another example. Find all numbers at which f is continuous. I will think about the domain. So the good option to start solving these types of questions when they are asking about find the number, all numbers, and they didn't give me a specific number like the previous questions, I will find the domain. Domain all real numbers except the 0 because of the undefined denominator. So there is an asymptote line. So in this case, f when I substitute by 0 will be undefined. For that reason, I will say it's continuous at every x value except the x is equal to 0. Some of you now are asking, "Top teacher, why you said it's a continuous at all?" Because if you remember the graph, and I told you, the best understanding for continuity and the limits, always understand the graph. Do you remember the shape of the graph of this? You will understand what I'm saying over here. Next, part B. Now, what about also another rational function? And the question is asking for find the values of which x will be continuous at. The same thing, I'll study the domain. So the key to these types of questions, when we see rational functions, it's studying the domain. So R except, of course, the 1, all real numbers except the 1. So when I say f of 1, the first condition will fail, which is the undefined. Did you see what I started over here, the conditions? So no need to continue the second condition. Now, why to recall an information over here? Because some of you will tell me, "Teacher, this one can be factored. Why you didn't factor that?" But even if it's like the graph will change to a line, if you remember, and this is a recall information from what you took in grade 10 last year. What happens when you want to graph this one, y is equal to x plus 1? It will be as simple as that, a line. But don't forget, even if you cancel the x minus 1 and there is no denominator anymore, but you must put a whole, so it's continuous at every x value except the 1. Okay, what about these types of functions? As you can see, do I have to study the domain? Of course, studying the domain over here is not an 0. Why? Because as you can see, changing from function to another function, add this 0. So I started by saying f of 0 equals, where should I substitute first? Equation or the second? Of course, the first because of the equal. Right and left. Where should I substitute for the right? Greater than. Where should I substitute for the left? Less than. And I got the answer. This is a 1. This is a 1. So this is the limit. It's a 1. So the first and the second condition are equal. What does that mean? Continuous at every x value. What about if I saw a question like this? D, f of x equals to x squared. Domain R. So there's no problem at all. So continuous at every x value. Done. So what about discuss the continuity of this function? From the previous example, what did you understand? What you will do? Excellent. You will study the continuity at -1. So I did the condition 1, 2. So first step, f of -1, where should I substitute? That's an easy one. Now right and left limit. Where should I substitute? Right, greater than, yes, thank you. Left, less than, thank you. And as you can see, this one it's a 1 and this one it's a 0, so it does not exist. So the function is discontinuity at x is equal to -1. Yes, that's it. Thank you.